All right, hello class, thank you for joining me. So today's lecture is in some sense going to finish consumer theory by taking the work that we've done to understand the choices of individuals and using it to allow us to make statements about markets as a whole. So essentially what we're going to do today, we're going to do two things. The first thing that we're going to do is we're going to use our individual demand curves, right, the work we've done to define individual demand curves, in order to produce market demand curves. And this is going to be important, right, because when consumers eventually interact with producers, they're going to do so through a market, right? An individual only matters in terms of setting prices insofar as they contribute to market demand, right? So that's the first thing we're going to do is create market demand curves. The second thing that we're going to do is we're going to use those market demand curves and the work we've done to define demand curves to understand consumer surplus a little bit more deeply and to learn how to calculate consumer surplus. So essentially, one way to think about this lecture is that in this lecture, we're finally getting to probably where you started in Econ 101, right, where we're drawing demand curves and we're calculating consumer surpluses. Only now, hopefully, we've got a deeper understanding of how those demand curves come about as a function of the preferences and constraints faced by the individual demanders. Okay, so to do this, let's start with the simplest market we can make, right? Let's say that we've got a market with just two demanders, right? Got a price. Let's say we're going to look at the market for whole chickens, right? And let's have two demanders here, right, to keep things really simple. Let's say the first demander for whole chickens is going to be Bigfoot. And the second demander is going to be the dread West Virginia Mothman. Right, so we've got Bigfoot, we've got Mothman. They've got different demand curves, right? Bigfoot isn't willing to buy any chickens if the price is more than $12 a chicken. And Bigfoot is full, doesn't want any more chickens even if they're free. If the price goes to 10, or once she's consumed 10 chickens, right? Whereas the West Virginia Mothman, a little bit of a cheapskate, not willing to buy any chickens for a price above $6 a chicken, but has more of an appetite, is willing to buy up to 20 chickens, right? So we've got Bigfoot's demand, we've got Mothman's demand. And our goal is going to be, right, how are we going to combine these to get to a market demand? So the only thing we need to figure out, right, is we're going to add these two curves together. There's two different ways we can do it, right? We could add vertically or we could add horizontally, right? So what does that mean? Well, if we added vertically, right, maybe we would say, well, at a price of, let's say, or sorry, if we're going to add horizontally, we would say maybe when Bigfoot and Mothman are both buying 5 chickens, right? Bigfoot's got a P of 5, Mothman's got a P of 5, Bigfoot's got a P of 6, so we should add them up and get 11, right? That would be summing up vertically. If we summed up horizontally, right, we would say something like, well, okay, at a price of 5, you know, Mothman's willing to buy 5 chickens and Bigfoot's willing to buy 6 chickens, so we should have a total demand of, say, 11 chickens. So think for a second about which of these two approaches make sense, right? In approach 1, when we're adding vertically, right, we're starting by picking a quantity and then adding the price associated with that quantity for Mothman to the price associated with that quantity for Bigfoot and getting a total price. The other way, we're picking a price, right, we're saying at $5, we're going to add up the amount that Bigfoot wants, Mothman wants to buy at $5, the amount that Bigfoot wants to buy at $5, to get a total amount purchased at $5. So which of those strategies makes sense? So I'm going to argue, right, that we've got to add horizontally, right? We've got to sum up horizontally because the thing that Bigfoot and Mothman share, right, is a price. When the price of chickens is $5, Bigfoot's going to want to buy 6, Mothman's going to want to buy 5. Together, they're going to buy 11, right? It doesn't make sense to think about when they're both buying 5 chickens, what's the price that Bigfoot will pay and what's the price that Mothman will pay, because it's not like they're putting together a collection to buy chickens, right? They're two individuals making two individual decisions. So we're not going to add vertically. We're going to add horizontally. And the reason is we want to add quantities together at a given price rather than adding prices, right? So the basic rule for market demand is the sum of individual demands right? We're going to add quantity demanded at a given price, which graphically means we're going to add horizontally, right? So when we're adding up Bigfoot and Mothman's demands to get to a total demand curve, right? At a price of 12, only Bigfoot's buying anything, right? All the way down to a price of 6. So our market demand is just going to be Bigfoot's demand up until Mothman gets in the game, right? Once the price falls to 6. From there, right, we're going to add their demands up together. So that right at a price of 0, where Bigfoot wants 10 chickens and Mothman wants 20 chickens, market demand is going to be 30 chickens. Right, if we describe this functionally, we might call this something like quantity demanded by the market as a function of price, right, where this is quantity demanded by Bigfoot as a function of price. This is quantity demanded by Mothman as a function of price, right? So that's all there is to it, right? This is our way to get into a market demand. So a couple of things to notice, right? Market demand always has to be at least as great as any individual's demand. Why is that? Because no one's ever demanding negative quantities of a good, right? I add up a bunch of positive numbers that are either positive or 0. I'm going to have to get a number that's at least as big as the biggest number, right? It's going to be bigger as long as all the other numbers are at 0. You'll also notice, right, the slope here is less steep, meaning an increase in price increases quantity more for the market demand curve than for either individual demand curve, right? The reason for that is because when all the individual demand curves are downward sloping, right, that means that each individual is buying more as we decrease the price. So the total increase in quantity when you decrease the price is going to be the sum of all the individual quantities, increases in quantity when we decrease the price, right? And that's going to end up being greater, meaning a flatter slope, than any of those individual increases in quantity. Cool. So hopefully so far so good, right? We're not doing anything too crazy so far. So what I'm going to do next is I'm going to talk about how to use this procedure, right, the logic in this graph, to solve a slightly more complicated problem. I'm going to use this to give us a little bit of practice in solving demand curves. So what we're going to do, we're going to calculate some demand curves for Bigfoot and for Mothman, and then we're going to figure out how to use those to get to a market demand curve, right? And in order to calculate those demand curves, I need more than one good, right? We can't just be talking about chickens to understand optimal choices. So let's imagine, I don't want to pigeonhole these cryptids as spineless eating machines. So let's say that we've got two goods. We've got chickens as before, and then we have paintings by the surrealist Spanish artist Salvador Dali, right? Because, cryptids have a lot more going for them than just eating. Right, so let's say that the price of chicken is going to be $5, and the price of a Dali painting, we're just going to call P, right? Or actually, let's leave it as PD so we keep track of what's what. Right, and what we want to know is how many Dali paintings Bigfoot and Mothman are going to consume, right, at different prices. And let's say for Bigfoot, her preferences are going to be given by, let's say they're Bigfoot's going to have quasi-linear preferences. So let's say she's got an income of 20 bucks, and her preferences are going to be, let's say, ln of C plus D, right? So she's going to have quasi-linear preferences. And then for Mothman, right, let's say that Mothman's preferences are Cobb Douglas. So for Mothman, right, he's going to have preferences U of CD equals ln of C plus ln of D plus ln of D. And Mothman is going to have an income of $50. Cool. Okay, so to start with, right, we want to find the individual demand curve for each of these cryptids. So let's start with BigFit. Right, the first thing we're going to want to do is we're going to find the MRS. For Bigfoot, which is just going to be du dc over du dd. Right, and as we remember, this is going to be interpreted as the number of dollies Bigfoot is willing to give per unit of chicken, right, to get a little bit more chicken at when Bigfoot is consuming C units of chicken and D units of dolly paintings. Cool. Right, and this is going to be the marginal utility of chicken over the marginal utility of dolly paintings. Okay, so let's find each of these marginal utilities, right? du dc is going to be what? Derivative of ln of C is just 1 over C. du dd is just going to be 1. So our MRS, right, it's just going to be 1 over C divided by 1 is 1 over C. Let's check to make sure that this makes sense. What we're saying is, as the number of chickens that we consume increases, the number of dolly paintings we're willing to give up per chicken decreases, right? And this makes sense. If I'm very, very, very hungry, I've got very little chicken, I might be willing to give up a lot of paintings to get another bite of chicken. If I'm pretty full, right, I'm not going to be willing to give up very many paintings to get another bite of chicken. So far, so good. So where do we go from here? Well, now that we have our MRS, we need to think about, are we looking for an interior solution or a corner solution? Right? In other words, are we considering situations where Bigfoot buys only chicken or only dollies, or only situations where Bigfoot will buy both? So in this case, we can rule out the corner solution where dolly doesn't eat any chicken, right? Because as C gets really, really, really tiny, the MRS gets really, really, really huge, right? When the MRS gets really, really huge, that means that Bigfoot will be willing to give up any amount of dolly painting to get just a little bit of chicken. So she's always going to buy at least a little bit of chicken. So we can rule out C equals 0, but we can't rule out D equals 0, right? It's possible that Bigfoot won't want to buy any dolly paintings. If we think about this graphically, right? We've got chicken, we've got dolly paintings, right? In order to have no chicken, we would need an MRS that's less steep than our budget constraint, right? Which we said isn't possible when we don't have any chicken. In order to have no dolly paintings, we need our MRS to be at least as steep as the budget constraint, right, when we're spending all of our money on chicken. So let's start by looking for the corner. Where D equals 0, right? Okay, so if we have a corner solution, right, we're going to consume all of our income on chicken. So we would have C, E of C times C equals our income, which we said was, what did I say the income was here? 20 bucks. Right, income is 20 bucks. Right, so C is going to equal, and the price of chicken we said was 5 bucks. 20 over 5 equals 4 pieces of chicken. Right? So that's going to be true if MRS calculated at 4 and 0 is greater than or equal to our price ratio, which is going to be PC over PD. Or in this case, since the price of chicken is 5 over PD. Right? So what's our MRS calculated at 4 and 0? That's going to be 1 over 4, greater than or equal to 5 over PD. So cross multiplying, we'll say PD has to be greater than or equal to 20. Right? So if you've got to pay more than 20 bucks for a dolly painting, Bigfoot is going to say, forget about it, right? I'm going to spend all my money on chicken. So that's our corner. How about our interior solution? Right, so in our interior solution, We would be buying some dolly paintings. We would be buying some chicken, right? We've got a solution like this. So we're going to have our MRS equal to the price ratio, right? So MRS of C and D has to equal PC over PD, right? So 1 over C has to equal 5 over PD. Cool. So C is going to equal PD over 5, right? What do we do now? Now we plug this into our budget constraint to get the number of dollies, right? Right, so we know that PC times C plus PD times D has to equal our income, right? So that means 5 times PD over 5 plus PD times D equals 20 bucks, right? So what does that tell us? It tells us that PD plus PD times D equals 20, right? D, PD times D equals 20 minus PD. D equals 20 over PD minus 1, right? So we've got two conditions here, right? We have a corner solution where we buy 0 dollies if the price of a dolly is greater than 20. If the price of a dolly is less than 20, we're going to have an interior solution, right? Because we've ruled out both corners. And in that case, the number of dollies we're going to buy is 20 minus the price of a dolly. So we can take these two pieces of information, we can put them together to create a single piecewise function that tells us how many dollies Bigfoot is going to demand at any given price of a dolly paint, right? So we're going to get QDB as a function of the price of a dolly painting is equal to, right, 0 if PD greater than or equal to 20, right? And it's going to be 20 over PD minus 1 if PD is less than 20, right? One thing to notice here, and this should always be true, is that these two conditions are equal when PD equals 20, right? If the price of a dolly is 20, we're going to buy 20 over 20 minus 1 is 0 dolly paintings. The reason is you can think of that situation as almost being a corner solution and an interior solution, right? It's on a corner, but it satisfies our criteria for an interior solution because the MRS is exactly equal to the price ratio. Cool. So that's our dolly demand for Bigfoot. Let's figure out our dolly demand for Mothman. Okay, so we're going to do the same thing when we're solving for Mothman's market demand, right? We're going to figure out at any given price, PD, how many dolly paintings Mothman is going to buy. And once again, let's start by calculating Mothman's MRS, right? So we can say our MRS, DC, right, is going to be du DC over du dD, right? We'll say du dC is going to equal 1 over C, and du dD is going to equal 1 over D, right? So our MRS is going to be 1 over C divided by 1 over D equals D over C. And let's again do a double check here to make sure this makes sense. What we're saying is the number of dollies I'm willing to give up per unit chicken, right, per micron of chicken, when I have C units of chicken and D units of dolly paintings, is higher the more dollies I have, lower the more chicken I have, right? So when I'm really full, I am willing to give up fewer dollies. That makes sense. When I've got a full art gallery, I'm willing to give up more dollies. That makes sense too. So great. Okay. So now that we've checked our MRS, made sure that it makes sense, let's think about whether we need to worry about corner solutions. In this case, right, if we've got no dolly paintings, our MRS is going to be 0, which means that we're not willing to give up any little bit of dolly painting to get more chicken. Can't possibly be at a horizontal corner solution. If we have no chicken, our MRS would be infinity, right? We would be willing to give up any amount of dolly painting for just a little bit of chicken. So we can't possibly have a vertical corner solution either. So we can go straight to trying to find an interior solution, right? Right, so what are we going to do for our interior solution? First, we're going to set MRS equals our price ratio, right? So D over C is going to equal 5 over PD, right? So why don't I solve for C here as a function of D? So we'll say C equals D times PD over 5. I could do it the other way too, but this way we'll get to our function of Dali's a little bit faster, right? So this is how much chicken we're going to buy. What do we do with that? We plug it into our budget constraint, right? So then we say PC times C plus PD times D has to equal our income, right? So 5 times D times PD over 5, right? Which is our value of C, plus PD times D has to equal 50 bucks, right? Obviously the 5's cancel here. So we're just going to have D times PD plus D times PD equals 50. In other words, 2 times PD times D equals 50. D is going to equal 25 over PD, right? This is going to be our solution. So as a result, when we're writing our demand curve for Mothman, right, we'll just say QD of M as a function of PD is just going to equal 25 over PD. Cool. So now we have Bigfoot's demand curve and we have Mothman's demand curve. All we have to do is put them all together to get a market demand curve. So just as a reminder, right, what we're going to try to do here is sum up our demands horizontally. We've got PD and QD. Just say D. Right, let's say at a price of 30, 20, 10, and 0. Right, we know that our demand for Dali paintings is 0 until we hit a price of 20. And then, sorry, our Bigfoot demand for Dali paintings is 0 until we hit a price of 20. And then it decreases according to this, right? So at a price of 10, we're going to demand 20 over 10 is 2 minus 1. Let's see, 1, 2, 3, 4, 5. Right, so we're going to have a demand of 20, 10. If we had a price of 5, 20 over 5 is 4 minus 1 is 3. Right, it's going to look something like this. This is Q, B, PD. And then Mothman's demand, right, is always going to be positive at a price of 25. Mothman will demand 1, right, 25 over 25. At a price of, say, 10, Mothman would demand 25 over 10, which is about 2.5, right? At a price of 5, Mothman will demand 5. Right, so Mothman's demand curve looks more like that. Right? And when we want to find our market demand, we're going to sum horizontally. Right, we're going to do this. So how we're going to do that, right, is we're going to sum up these two functions horizontally. So we'll say our demand total demand as a function of the price of a Dali is just going to be our demand for Bigfoot plus our demand for Mothman, right? So it's just going to be this piecewise function right, plus this ordinary function. Cool. So how are we going to deal with this mass? Well, remember, right, 25 over PD is just 25 over PD if PD is greater than or equal to 20, and 25 over PD if PD is less than 20, right? So we can say here, it's going to be 0 plus 25 over PD if PD is greater than or equal to 20, and it'll be 20 over PD plus 25 over PD if PD is less than 20, right? This is just gonna be, right, 25 over PD if PD is greater than or equal to 20, and 45 over PD if PD is less than 20, right? And this is our market demand curve. Okay, excellent, excellent. Okay, so in the next video, I'm going to spend a couple of minutes